I'll also stand up in a minute, I promise. This is good. That's good. And everybody can see? Yay. Boy, if I stand up, I'm going to be in everyone's way. That's fun. There. Now you can all see me. All right. Yeah, I'm Jen McCown. I'm one half of MidnightDBA.com. I'm sure all of you are avid fans. Probably not, actually, but that's fine. My husband, Sean, is a SQL Server MVP. I'm a SQL Server not yet an MVP, maybe in a couple of years. And I've been in SQL for give or take 10 years. And, Midnight DBA. We do free IT training videos. This is all just on our own time. So I largely do T-SQL, but some other things as well. Sean likes to do PowerShell, Windows, SQL, and just whatever we feel like. We've got a couple of podcasts we do. My blogcast is my audio only, beginning to end, reading blogs. Which, when I say it like that, it sounds a lot more boring than it is. It's just me reading stuff. But and then the DBAs at Midnight web show is actually picking up pretty well. It's just me and Sean sitting around talking about whatever we feel like. A couple of weeks ago, we got together with some friends in Seattle, some of the online Twitter SQL guys, and got to sit down and complain about the latest round of plagiarism going on in the SQL community. So that was a lot of fun episode. A little rough language, some rubber chickens being violated. That's just watch the episode. I'm not going to explain that. All right. So this says, by the way, if a pretty poster and a cute saying are all it takes to motivate you, you probably have a very easy job, the kind robots will be doing soon. And I'm kind of looking for excuses to put these in because I think they're funny, but the idea of being motivated to learn, all that. All right, why a beginner's kit? Beginning SQL, you're not going to learn what you need to know in an hour, even with someone as awesome as me teaching you. So what we're doing today is giving a real whirlwind tour of the very basics, and then I've got, I will have up on that link a set of resources to go to, and different kinds. So if you want, you can pick out one of the books that sounds good to you that I recommend, or you can go to the blogs, or you can read through the BOL articles, or so forth. Or, you can mix and match all you want to. So you get the presentation here, which will also be recorded and online, with any luck, and the resources as well. So your number one reference with SQL is SQL Server Books Online, BOL. It comes with the product if you download it. SQL Express, by the way, is free. You can download that and install it for your own purposes. You can download BOL just on its own, and it's also available online at this address. Actually, I escaped out of that so that we could go online and see it, but I don't think I have connectivity right now. But anytime somebody says RTFM, that's what they're talking about. Once you have RTFM'd, then you can come and ask bunches of questions. So we're going to, I hope, have a little fun with this today. I went back and forth and decided we should really, T-SQL Basics, even for beginners, is kind of a dry topic, right? Let's have a little fun with it. We're going to make a couple tables in our database. What should we make it about? Past suggestions have included goats, socks, plants, whiskey, toothpaste flavorings, spitting, hubcap styles, Doctor Who factoids. What do you guys want to talk about today? If I'm going to default to chickens if you don't come up with something fun. Anybody? Patience? Patience in a hospital? Yes. It could have been the virtue. Patience. The virtues. Patience. Anybody else has anything that they like better? Beer? I was going to say alcohol. That's a good one.
I love that.
We like beer?
Lumberjacks.
Lumberjacks. I could see how those two would be related. I really can. All right. We're going to hop over to, we're going to do a new query window. Is everyone familiar with Management Studio? Anybody at all? Okay, cool. So you know that you can type things in there. Let's start with a comment. We're going to make a table about, we'll start with beer, and maybe we'll kind of factor in lumberjacks, because there's only so much I know about lumberjacks.
Then you'll end up with patience.
Then we'll end up with patience. I like that. Hang on a second. Hang on.
Oh, prizes?
Yeah, prizes. Chocolate. All right. Okay, so we're going to make about a table about beer which I like. Okay, so T-SQL itself, SQL is the ANSI standard database programming language. Presumably, that's what's going to work on every database platform. It doesn't, because the ANSI standard is huge and it encapsulates a lot of things that we don't really need. So each vendor, like SQL, Oracle, and so forth, they do their own implementation of SQL. Microsoft's version of it is called T-SQL, Transact Structured Query Language. That's what that stands for. That's okay, you can look at it. I'll have to write that down. The big thing, I didn't actually want to start with transactions because I'm like, all T-SQL beginner's book starts with transactions. And then I realized after a while, there's a reason for that. The big thing you need to know about SQL Server is that everything you do is done in a transaction. It's just a unit of work that is sink or swim. Either the whole thing completes successfully or the whole thing fails and has to be undone. That undo is called a rollback. So you'll hear about that. The transaction was committed, the transaction was rolled back. Now, each statement, like, select from database or update table, right? Select from database. I'm a noob. Each statement is itself an implicit and understood transaction. Either if I update this table, either everything I'm updating will update, or it's going to fail and nothing will get updated. It's not like you're going to update 10 rows and 5 of them will be updated and the others won't. You can also explicitly say, I want all of these statements to be in a transaction, and then if one of them fails, the rest will fail. I'm getting a timeout on that. And just for funsies, let's do a real quick, it's not in there. Why isn't it in there? I have an example. Let's see if we can find my example of transactions. Any questions so far? I know we've covered so much. Okay, cool. SQL Beginner's Kit. And, all right, I can't find it. I was going to show you how it fails and rolls back, but I'll make sure that that's on the website. Can't find it. All right, here's my demo. That's not there. Okay, tables. Tables are what holds your data in SQL Server. Now everyone's kind of familiar, we've seen tables, online, we've seen tables probably in Excel, that kind of thing. So it's kind of basically understood. A table has different attributes in it. This particular table is about rooms. This table is modeling something in real life. It's modeling a room. And these are the things that we want to know about that room. We want to know its ID, what building it's in. Each one of those columns has a specific name and data type, which we'll get onto. Each row in a table represents one of whatever we're talking about. So let's go build our beer table, and we'll figure out what we want to know about one beer. So it's very simple. Create table beer. And I go by the syntax of, it's one thing, so instead of saying beers, it's beer. What do we want to know about beer? What do we want to have in our database up here? Probably like the domestic or import. We'll say is domestic, because if it's not a domestic, it's import. Let's start with the name of it. Beer name. Now beers have different makers. So Budweiser has Bud Light, and they have Bud Dry and Bud Ice and Bud all that kind of thing. So we want what would you call that? The beer maker. If you have a better name than that, go for it. We'll say brewer. Thank you. Brewer. What did you say? Alcohol content. I like that. ALCOHO. That's not right. Someone spell alcohol. ALCOHOL. Content in it goes by percentage, right? All right. That's not bad for a start. Brewer. This is why they say you never type in live demos, because everything you type is going to be wrong.
Isn't that kind of light and dark?
Light and dark. We're going to go by say like category. So you've got loggers and you've got we're going to call it category. 5 is a good place to start. Absolutely. And we'll go ahead and make a note of that. Lager, Pilsner, Stout, 2TL, etc. That is a comment. Oh yes, and you've got the stout pilsners from Germany, which are actually called Achweinestung. All right, so okay, great. We've got names of columns. That's absolutely brilliant. we'll take a moment to appreciate this. I didn't make this. The simplest solutions are often the cleverest and wrong. The simplest solution to typing your data in a database would just be to make them all strings, because you can store absolutely anything in a string. I can store numbers, I can store phone numbers, I can store words, I can anything at all. The problem with that is the data type determines what you can do with the data. If you store absolutely everything in a string, you couldn't do math functions on that. You can't add, logger plus, ale and come up with anything meaningful. You couldn't add a month to Pilsner and have it come up with something meaningful. In addition to that, we've got space issues, which we'll talk about as well. And I'm saying don't write all of these down because it's all in books online. Don't sit there and scribble because we're going over several different types. In SQL Server, you've got a bunch of different numeric types, including in your integers alone, you have 4 different types. And that's because you can have an integer that only ranges, like if we're going to count somebody's age.
127 or something?
I'm sorry?
That's just like 0 to 127 or something?
Tiny int goes from 0 to 255. Small int goes from negative, I think it's 32,000. Don't make me quote numbers at you. That's why I have books online to look up those numbers. But yeah, each one has a different range, and each one has a different storage size on disk. If we're counting somebody's age, somebody at max is going to be 110, 120 years old. They don't get any older than that, and nobody's going to be negative anything. So why use an int, which goes to like a negative 2 billion and takes up 4 bytes of space in the database? Use a tiny int and save yourself 3 bytes. Tiny int is 1 byte. That becomes, even on your own personal databases, if you've got your beer database that you're putting together, you don't want to waste space just as a matter of principle. And on production databases in the real world, you don't want to do it because space is money. Disks cost money, and you will eventually be talking about this small project growing into a multi-company application that has millions and millions of rows in it. Be conservative with your space while using appropriate data types. Don't short yourself. All right, so we've got our integers. We've got decimal and numeric. We've got float and real. I'll let you read up on the difference between fixed precision and non-fixed. This is one of the things we're talking about when we say it's a whirlwind tour. And we've got money data types. We have date data types, a bunch of different types, again, with different ranges and different levels of accuracy. So like small date time is accurate down to the second. Date time is accurate down to the, it's either millisecond or, no, not nanosecond. It's like one's a millionth and one's a, anyway. It's more specific. We've got different kinds of string data types. You might kind of think, well, a string's a string. What's the big deal? We'll talk about that. Notice you've got the char data type. I realize it's char. For some reason, we always say char. Char and varchar. Char is a fixed length character data type. Variable, and varchar is a variable length. Okay, what does that mean? I don't even know what you're talking about, right? I managed to shut down my solution, so let's open that back up again and look at the code. Where'd you go? Come on, where'd you go? Well, fine then. We're going to open up the file itself. Okay, char versus varchar. We're going to jump right into a little bit of code. Don't worry if you don't understand it all. You can declare variables. This is what a variable looks like. It's got a little at symbol in front of it. And then give it the data type. We've given this first one a data type of, y'all can sneak out whenever you need to. I'm not going to be offended. Let me throw, oh, you've got the intro, that's right. Of char 100, and then we've got varchar 100. We're going to assign a value to each one of those. And it's just my name, right? Thank you. And here we're going to select those variables. We're going to display them. And I've done a string concatenation where we're adding a fixed string, start, to the variable, and then an ending string just to show where it ends, right? And the same thing on char and varchar. You got to actually do the whole thing, Jen. So our char data, it's a fixed string because even though you only put 3 letters in it, it's going to pad the rest of that available space, the rest of that 100 characters with blanks. So it actually stores 100 characters on your disk no matter what. Varchar says, you only got 3 variables in there, let's make this a short string. Now, the difference in cost is that with varchar, you've got plus 2 bytes. The size to store a character data type is 1 byte per character. Varchar is 1 byte per character plus an extra 2 bytes so that SQL knows how long your string is. most of the time, those extra 2 bytes are worth it because you're saving like, 80 or 90 characters on your string. Moving right along.
So that now we specified 100.
That's how many characters in your string.
That's the limit.
That's the limit for that particular data type. That's a really good question. We can make these 1,000. Not 100. We can make them 2,000. The top actual number you can put in there is 8,000 characters. There's also a varchar max, which is another. It's a different story, and we'll.
It's like putting comments if you want to type comments.
String data types.
Well, yeah, like
That's
it's kind of like blob, I guess.
yeah. It's you can use it for storing comments like that. Generally speaking, for my databases, if I'm going to make little notes on whatever the item is, it's not going to be more than 8,000 characters. But absolutely, you can store like whole documents worth of stuff in there.
In what?
In varchar max,
Which has how many characters?
up to 2 gigabytes worth of data.
Oh,
So that's one of the things that like I said, I'd like to get into, but we should probably skip over and then you can look it up. But know that it exists and that you can store up to 8,000 characters or use varchar max to store very big amounts of data.
That would be CarMax. You're in varchar max.
varchar max. Yeah, I don't think there's such a thing as CarMax. Thank you. CarMax is a car company.
I was going to say, if you're going to store 2 gigabytes in the car,
It should be varchar. Yeah, absolutely. I don't know that that's even an option. That's a very good point. So let's start assigning some data types. Beer name, that's clearly a string. Let's say varchar. The longest beer name, let's say we've got a German beer that's like over 100 characters. So we'll say, reasonably speaking, probably no more than 200, right? Brewer, same thing. We'll overshoot it a little bit just for fun. Is domestic, got a couple different options. You've got bit, which stores bit data. People generally use that to store 1s and 0s. There's also tiny int, which, like I said, it goes to 0 to 255. Both bit and tiny int are very, very small data types. You can use either one. I'm used to using bit. Alcohol content in percent.
I've seen people use like a car 5
Yeah.
for true false data.
You can. It's just so much more efficient instead of that 10 bytes that you're using to use 1 byte and say on off. And it's really, that's really another good question, actually. I like that. So let's talk about that for a minute. Let's say a couple of the exceptions, by the way, to always using varchar. For U.S. state, if you're defining in your database that that's always going to be a 2-character abbreviation, use car 2. It's either going to be empty or it's going to be full. Single letter variables should never be varchar because you're wasting 2 bytes. Either it's got a letter in it or it doesn't. You're not saving anything. Don't use varchar 1. Just saying. So, I'm sorry, tell me your question because I got tangented off.
No, I didn't have one.
Your comment.
I had seen I've seen a database where someone used
That's right, that's what I was going to say.
Var5 or varchar 5.
The problem with that is that if you do is true as a string, well then people can put in T, they can put in true, they can put in yeah, they can put in I think so. That's the thing, and that's something that you'll want to either use constraints, which is something else we'll go over, to take care of, or to define it on the front end. You've got an application that just returns your 1 or 0 so people can't mistype true or false. It's a really good thing. Okay, so alcohol content in percent. Let's see. We want to go back to our numeric data types and say use something like, let's see, fixed precision numbers. We'll say decimal 13.5. If I remember correctly, 13 is the total number of digits you can have, and 5 is the number of those that can be behind the decimal, if I'm remembering properly. But I think I am. Well, let's call it 13.2. That is correct. Thank you. Thank you very much. And category, we'll have another string. Sorry. Back to my Perl days. Let's make something up so that we can just have an integer. Here we go. I got an idea. How much I like it on a scale of 1 to 10. Very subjective, but this is our database and we can do whatever we want with it, right? All right, so moving right along again. All right, we've got date, string, come on. We did our create table, we gave it data types. So now we can just create our table, right? No. There are certain things that cannot be known or that cannot always be known. And this is true in real life. And this is true in databases. The way we deal with unknown data is with nulls. There is some religious debate about the use of nulls, but to my understanding, and since I'm teaching this class, it is very acceptable and it is the proved method to use null to mean I don't know. That's what it means. It means I don't know. While you can use some special value to denote I don't know, we have this lovely preset available thing. So null means I don't know, which means you can't compare it to other things the way you can a real value. You can't say is 3 equals to I don't know. There's no way to answer that. That's going to come back with an error. Nothing can be not equal to no. Is 3 not equal to no? Pfft, I don't know. So you have to use the special field, the special command is null, just to test whether it's null when you have that need in your database to see if it's null or not. When you create your table, everything is nullable. That is, you will allow null values in it by default. But if you want to disallow that, you say not null. Now, I encourage you to use, for those fields that you feel should be able to be nullable, to go ahead and say null. That says, I will allow this to be null if you like. I need a beer name. I need something to identify what we're talking about. But other than that, I'm going to allow it. All right, so can we create? Yeah, I'm jumping along here. Hang on a second. Can we create our table now? Yes, now we can create our table. So we'll run up here. Hang on, let me format this in a pretty way and hit execute. We now have a real table. We finally got there. How long into the presentation? Like 20 minutes? But we did well. We made a good database. Let's select some data out of it. Select beer name and brewer from our table name, beer. It's a select statement. It's what you use to get your data back out of the database. And right now I'm saying, okay, get me all of the beer names and brewers in the table. Well, we haven't put any in, so of course there's not going to be anything. But we need to know that the table is there. It exists. Oh, here. This is a bonus. SP help lets you get information about your tables and about the database as well. And that's on the bonus slide at the back. So we know it exists. We're able to select from it and see there's nothing in it. All right, let's talk about inserts. We did that. We did that. Inserts, you can insert a row into the table. Of course, you need a way to get data in. Now, when you select from a table, you have to include a column list of some kind, or select star, which we'll cover. Don't use that in production. In an insert statement, it's optional to say insert into table beer, and then our column list, and then our values list, right? Technically, you don't have to provide your column list. You can just say, okay, well, the first one is beer name, so I'm going to put in Bud Light. Sorry for those who don't like Bud Light. I'm not fond of it myself. Brewer Budweiser, and so forth, and fill in everything. It's not a good idea. Always include your column list. Any idea why?
You don't want to, probably want
It's okay.
you don't want to put everything.
You don't want to...
You don't want to put everything in at once, or you don't know which one to put in.
You may not want to put in everything at once, but there's another thing. Your table may change one way or the other. You can't. You can't always guarantee column order. You can't always guarantee column name, or that they're even going to be there, or that's all there is. So don't break your production code. Always put in the names. Now I'm going to do one of my standard things and get the column lists here. Copy that, stick that in here. I really don't like tapping that stuff out. And here, let's format. Oh, I can't format that yet. All right, let's finish putting in our values. So is domestic? Yes, it's a domestic beer. I don't really know what the alcohol content is, so I'm going to say that's null. Notice that's not in quotes. It's not a string. That's a database value. What category? I don't know, we'll call it light beer. How much I like it on a scale of 1 to 10? I don't know. How much do you guys like Bud Light? We'll take an average. Not so much?
1 or 2.
We'll give it a 1. I'm all for it. Here, we'll format that so it looks nice and pretty. That formatting thing I'm doing, by the way, is an add-in tool that I have, SQL Prompt. That's not something you can do automatically natively.
It's a freebie, right?
No, it's not, but it's a really good product, and I love it, and they don't pay me to say that. So let's insert a value. We'll execute it. Hey, look at that, one row affected. Now when we go in and we say, give me data out of my... Hey, look at that. I want to see everything in there, though, and I'm lazy, and this is a demo and or development, so I'm going to say select star. Select star means get all of the columns in the database. Again, you don't want to use that in production because tables change and you're going to break something. And not to mention, you very rarely need every single column out of a database. You're making SQL do more work than it has to. Those that were in my last session have already heard this rant, so sorry about that. One cool thing that you can do here. Let's pick another one. Let's see, Miller Lite. Now let's get off the sucky beer. Let's go for harp, and that's a lager. And I like that. It's not domestic. It is foreign. No idea what the content is. It is a lager, I think. Pretty sure. And I like that one very much. I'm going to do that. Harp is good. Another favorite of mine is Guinness. And this is about you guys. What's good beer for you?
You need to put Sweetwater down.
Yeah.
Sweetwater?
Sweetwater.
Is that one word or two?
One word, right?
Okay. All right. What?
Sweetwater, actually, do Sweetwater 420. Yeah, 420.
Oh, I messed up. Harp is actually done by the Guinness company. We messed up. Look at that.
Unless somebody else is a fan of a different kind of
Actually, just replace your logger, because you typed logger for...
Oh no, did I put that in the wrong thing?
Uh-huh.
Okay. But we haven't run this yet, so that's good. Notice how I'm starting up a comma and then a new result, a new values list. This is fairly new. This is new in 05 or 08? It's new in 05. New in 08. Okay, thank you. I always forget because I started working at 05 and 08 at the same time. You can insert more than one row at a time, which is just great that I don't have to copy paste that insert into statement over this part of it over and over again. So I've got one values list and I'm starting up a new one. So Sweetwater is made by, is it just Sweetwater?
Well, actually, the name of the beer, I guess, would be 420. Yeah, 420 is the beer. 420.
Okay, and that's the brewer. Is it domestic? Yes, probably, since this is alcohol, and we still don't know the alcohol. You know what? We're going to say this one has really high alcohol content, because, you know, beer does. Here, wait, really high alcohol content, right? This is a beer! Beer for men and strong
One beer
women.
and you're done.
Absolutely. All right, I'll back it back down. Let's see, alcohol content category is ale? Ale. See, this is so much more. Talking about beer is interesting. How much do we like Sweetwater? Do we like it a lot? We love Sweetwater. It's awesome. Give it a 10. All right, so I'm going to, when I highlight, by the way, that prevents me from running everything in the window. If I just ran this statement, it would go up here and try to run the create table and all that kind of thing. Matter of fact, in a minute we'll move to a new table, a new window. So we've got our harp and we've got our Sweetwater, and we run it. 2 rows affected. Awesome! We have data. Data is awesome. All right, now that we've got some data in there, let's take a look at whatever I was going to talk about next. We did multiple rows. That was our demo. We did that. All right, where? We don't always want every single row in our database either, because that's a lot, and we don't care. The where clause is what limits how many rows you get back from SQL Server. So, you know, let's do a demo on that as well. I'm going to move this on over to a new window because I'm tired of looking at it. Select star from beer. Where, let's see, what was that column name? How much I like it. I'm sorry?
Is domestic.
Oh yeah, I like that. Is domestic is true. What have we got that's domestic? 2. We've got Bud Light and we've got Sweetwater that are domestic. Or how about is domestic is not equal to 1? Hey, look at that. We've got one that's not. There are lots of different ways to do things in SQL Server. If you want everything that's domestic, you can say equal to 1. If you want everything that's not domestic, you can say not equal to 1 or equal to 0. Since there's only 2 values, you know, not is the other half. Okay, so there's our where condition, and we can do that for anything. How much I like it is greater than...
Do you always have to refer to it, or do you always have to call out 0 or 1? Or can you ever go for true, false, yes, no, on, off?
Since that's not a Boolean type, it's actually a bit type.
You gotta go 0, 1.
You got to go 0 or 1. We don't have a specific Boolean type that says true, false. No, because it's simply more efficient. You know, if you really want a Boolean, you can artificially create one. You can make a user-defined data type with string and then varchar and then like a constraint on it. But it's usually too much work. You don't want to reverse engineer all that. You can have multiples. And here, let's say how much I like it is greater than 2 and is domestic. Do we have anything that's domestic? And I like it that much? Hey, look at that, it's Sweetwater. That is a good beer, go figure. So you can add and columns and you can add ors. It's either I really like it or it's domestic. Either one's fine. I want all those back. And so forth and so on. All right. We got where conditions down. All right, so what if we want to update our data? What if I've decided, you know, maybe HARP, I found out the alcoholic content and it's 15. We want to update ATE, our table beer, and set the value. You notice how SQL is really kind of natural language, you know, not strictly across the board, but that was on purpose. Update beer, set alcohol, oh, that's a long name. Set alcohol content in percent to, what did I say, like 15.4, for example. Now, what happens if I run that right there?
All of them.
Yeah, there you go. You caught it. It will update every single row in my database. Do not update without a where clause. Do not delete without a proper where clause. And do not do either one of those without testing it first. Don't run, update, and delete in production. Just saying. Okay, so we want to set that equal to where beer name is equal to HARP. That's not it. That's it. And then we can take a look at our data and see, oh, good, we got that in there. So, okay, we've got updates.
SQL Server 2008?
Yes, it is.
Okay. I know in SQL Server 2008 we have the Intellisense enabled.
Mm-hmm.
So
I turned mine off.
Oh, okay.
I know, but it bothers me more than it helps me. So SQL Prompt actually has Intellisense too, and I turned that off too. It's like, oh, stop doing that. I don't know. It's a me thing. Intellisense, by the way, SQL 2008 will automatically complete like field names for you when you start typing them stuff. It just bothers me. I don't like it. All right, so we did our lovely update statement. Any questions so far? You guys good? We getting bored? Everything's wonderful. Put more beers in there that we like. So we already did our where condition. I don't remember why I put this in here. I will in a minute. Let me sneak ahead and see what I did. Oh yeah. It's all about me. You need to uniquely define, that's kind of a stretch, you know, it's Captain Kirk, he's unique. We need to be able to uniquely identify rows in a database. We just saw that we had to be able to do that, right? Because I was only talking about one particular beer, and I needed to update just that one particular beer, as opposed to all of them. Or I need to find out, that's good for a start. The way that we uniquely identify and enforce uniqueness in a table is with primary keys. The definition of a primary key, it's a little cumbersome at first, is the minimum number of rows that uniquely identify a row. So for example, in our database, HARP may or may not be, the HARP by Guinness may not be the only beer in the world named HARP. So we can't just say, okay, our primary key is HARP and that uniquely identifies it. We would need to figure out, all right, what is it that uniquely identifies this row? Let's take a look at our table real quick. Our table definition. What of these columns uniquely identifies our row? Beer name and brewer? I'm going to say probably. I don't think that Guinness is going to come out with two beers that are both named just HARP, because that would be very confusing and bad marketing. So that would be our natural primary key. Natural because that's what's in the database. And there's only one primary key per table. There's no point in coming up with two different ways to uniquely identify. You can have a unique column on a database, but that's a different story. Let's see. What do we got next? All right, so let's add a primary key. You can define your primary key when you create the table, or you can do it after the fact. It's generally best to do it when you create your table, but, you know, we just remembered. So let's see. Alter table, okay, constraint, primary key. I do this rarely enough to update the table with a primary key. Alter table, stop that. Alter table. It's because I keep hitting my mouse pad and it Yeah. Alter table beer. Add constraint. AINT. Oh, good. And then the constraint name. PK underscore is the convention generally, but you don't have to name it that. PK beer. Primary key, and I'm going to say non-clustered and explain that later. And then what columns is that on? Well, it's on beer name primarily, and then it's on brewer. Let's see if this will work for me. Cannot nullable. Oh, I forgot. Alter table. Hey, you know what? No. I want to do it the lazy way since we have almost no data in there, and I'm going to say you can't allow null values in any column that's into the primary key because you can't say, well, I don't know what the vendor is. Well, that's how you uniquely identify it. So I'm going to drop and recreate our table because for me it's easier than actually doing it the right way and altering the table. I know, but it's in development, so it's okay, right? So we're going to create the table. We're going to insert our values. All is well. Why are you doing this to me? This is why they tell you don't type SPL.
So you don't have issues with multi-column primary keys?
We'll have that discussion.
There's big.
That's another religious debate, and that's like the next slide. Absolutely, there are natural keys. We lost our domestic beer. That's okay. Screw Bud Light. We don't want it in our database anyway. No. All right. Select beer. Okay, we're doing an alter table to add a primary key, right? So if you wanted information to see, okay, beer table. Tell me, does it have a primary key on it? I've got a shortcut for SP help. That is displayed down here. Say non-clustered unique primary key on beer name and vendor. Okay, great. So that means if we were to try and go in now and insert those same values, that it would say, you can't do that. We've already got a row. This kind of constraint is what keeps your data from doing things that are weird. It's very important. Like if you have a customer database, to uniquely identify a customer and have him in there just once. Because what if you put him in there once, put him in there again with a different address? Well, which one's right? Put him in there once, put him in there again with a different phone number, with a different whatever in a medical database with a different allergy. Oh, now we're getting into trouble. Natural primary keys versus surrogate primary surrogate. Yeah, that's right. Versus artificial or surrogate primary keys. A surrogate primary key is an artificial one. It's one that you create and say, here is a row, or here is a column that I'm going to make purposefully unique so that I can identify it. Well, why would you want to do that? Well, like we talked about before, string data is really big. It takes a byte per character with varchar to identify it. Your primary key is used to uniquely identify. You're going to be comparing against that. You're going to be sorting against that. You're going to be doing all kinds of things. Oftentimes, you're going to be indexing against that, which we'll talk about. So you really want your primary key to be as small as possible. She's nodding off. I know it's beginner stuff. You know what? You nod it off, you get chocolate. I'm rewarding bad behavior. Here you go. There you go. And here, you're looking at me most intently and taking notes, so you get it too. Let's see. And I get a Coke. Okay. Unless you guys want it, but I need it. The concept of a primary key, of a surrogate primary key. We kind of good on that? Did I do okay? Okay, so far so good. Let's go ahead and create another table with a surrogate primary key, just so we can see what it looks like. I should say artificial. It's a better word. Let's see. Create.
Lewis used both. Lewis was making a little bit of distinction between them. And I don't remember what it was.
Surrogate primary key.
What is it, artificial?
Artificial. We'll go with artificial.
His slide said natural and artificial, but then his next slide he started talking about surrogate. So there's some subtle difference.
I'm not sure that there's necessarily a difference, but we're going to create.
Very nuanced. I mean, from everything I've ever learned, it's natural and surrogate is sort of the baseline.
So we're going to create a lumberjack table in your honor, because lumberjacks like beer.
Surrogate then. I always stay away from anything that has anything to do
Yeah. Car. Now, the reason we would want to make a surrogate primary key, just like, here's number 1. Row number 1 is row number 1. Row number 10 is row number 10. Doesn't matter what your name is or what the data is. It's much smaller to hold and compare integer data, for example, than it is to compare string data. That takes a lot longer for the SQL engine to process string data. Think of it this way. We have phone numbers and we have names and we have web addresses, right? What do you remember the easiest? You remember words the easiest, easily understood. It's like midnightdba.com. That's something I can remember because I know midnight and I know a DBA. Computers don't understand words as well. They deal better and more quickly with numbers because they're number-based. Go figure. So we're going to do a lumberjack table. Favorite beer ID. And I know we'll fix that in a minute. So this is going to be our primary key. This will uniquely identify all of our lumberjacks, right? Putting it as an integer, that's fine, but we want to automatically number it in the database. The way you do that is with an identity, I-D-E-N-T-I-T-Y. Identity, that's exactly what it is. Automatically number this for me. Identity 1-1 is most common. It means start at the number 1 and count up by 1s. But if we wanted to, we could start at the number 11 and count up by 13s. I don't know. You might want to do that for a demo, but it's fairly rare. Let's go ahead and add a constraint, primary key constraint. So let's see. Y'all may have to help me because I don't type this very often. Constraint. Let's see. It's going to be a primary key non-clustered USTERED.
You're going to talk about the non-clustered?
Constraint name?
Yeah, we will.
Okay, good.
Yeah, it is constraint name, isn't it? PK lumberjack. Primary key non-clustered on ID. And I'm sure I got that wrong. It's a constraint primary key. Hang on. I know, it's embarrassing. I'm teaching a basic SQL class and I do this. Drop constraint.
That's what Books Online is for.
Yes, it is. Here's a good time to demonstrate SQL Server Books Online. Thank you. I did that on purpose. Thank you, plant in the audience. So, create table, right? So this is Books Online. It can be a little bit intimidating because each one of these things contains a lot of information, but you get used to it. You pick out the information you need, and my absolute favorite portion are the examples. You get down into the example section of any code. And this is on our create table, so using foreign key, using thing, wait for it. Showing the complete table definition. There's an example, and we've got our primary key constraint right here. And again, there's a lot of extra stuff in there. So primary key clustered, and we don't need to ignore dupe key off. All right, we're back on track. Constraint, name, primary key, non-clustered. Well, I had that right. Well, I don't know why it's yelling at me. I guess we'll find out, huh? Hey, it worked. So now we have a table that we can insert into. And when you insert into a table with an identity column, you don't insert that value. You say, okay, I'm going to insert full name, favorite, that column, values, whatever, right? We've got to go back and fix something. Because I put favorite beer ID to reference the beer table. Well, we don't have an ID column on the beer table. The way I did this the reason I did this way is so we can go back and fix our beer table and say, I don't want it that way. And again, we could do the alter, but I'm not going to. Drop table beer. Yeah.
Can I ask a real basic question?
Please, because it's in the title.
How do you know when to hit return and go to the next line?
How do you know? That's pure formatting. Let me show you something real quick. That's an excellent question, actually.
I'm really new at this.
SQL Server does not really care about white space. What you can do, God, that's a good question. You can do anything you want. That will run right there.
I'm getting it that it knows certain words, and I've got select from and where.
Mm-hmm.
But like when you, I guess after the non-clustered thing, how do you know to go to the next line or whatever?
It's purely.
Auto word wrap.
Yeah, this is auto word wrap right here.
It's styled though.
But yeah, it's just styled. That's just styled for readability. This is actually on one line. It's just word wrapped because that's the way I have it set up. Like you can set Notepad to word wrap, and it'll run
She's got a font bigger too.
regardless. Yeah, that too. So usually I don't have word wrap and I'll just scroll off to the side. But no, that's great.
Semicolon at the end of each one of your.
Nope. There was one particular case in SQL that you do have to put a semicolon on the line before, and that's with CTEs. But we're not covering CTEs today. And when you get to that, you'll figure that one out pretty quickly. But yeah, generally speaking, SQL never. You can absolutely. It makes you feel better if you're used to it. Nothing wrong with that. People do.
It always used to be required, right?
Not since SQL 2000. Not in SQL 2000 or later. If it was required before that, I don't know.
So semicolon?
Semicolon.
Oracle, SQL is that's required. But it's just recently I've seen things like there's some things in SQL Server now that require certain types of statements, but that's relatively new. But I know I came from an Oracle background originally, and you always had to have a semicolon.
All right. No, that was a great question. All right, so what we're going to do is we're going to drop and recreate our table again. You usually want to alter, but this is a demo. It's a demo. We're going to have our ID. It's an It's an identity 11. You don't really even need to put not null if you don't want to. I don't mind not doing it, but an identity automatically puts that value in, so you can't have a null. An identity prevents you from changing the value that's put in there. So after the fact, you can't update it to be something else. You can force the issue. There are ways to force the issue, but as it stands right here, you can't change that. So let's change our constraint not to be beer name and brewer, but to be ID. And we'll do our drop create, and we'll do our... Hey, look at that. We just changed what's in our table. We just added a column, and we do not have to update our insert statement because we included our column list. How awesome are we? Hey, look at that. It worked. I love when things work. Yeah. 10 minutes? Oh, crud. All right, well, we got primary keys. We're gonna fly a little bit, okay? We got that. We demoed primary keys. Foreign keys, if you want to interrelate data, which you do because you're in a relational database, you've got to tie your different tables together somehow. We've got a beer table, and we've got a lumberjack table. Let's go ahead and insert somebody into the lumberjack table. What's your name? You're a lumberjack. Lee. Smith is now a lumberjack, and his favorite beer is whatever 2 is. So we're going to put him in there. All right, so let's say we wanted to select from beer. Okay, great. We've got data in beer. Select from lumberjack, which I'm going to copy because I don't trust myself to type it right. There you go. And Lee's in there. How do we tie that together? We tie things together with inner joins and foreign keys. Now, the foreign key constraint, it's like our primary key constraint, only instead of saying this is a unique column, this here is a unique column that's going to uniquely identify my rows, it's going to be a constraint that I'm not going to type out right now because we don't have the time for me to get it right, that says this column right here references my column in the table beer. And that's exactly how it says. Let's look it up in BOL, shall we? Foreign key constraints, about foreign key constraints. And you can see here. So this table over here says, this refers to the primary key over here. I'm referring to that unique record. Let's see if it gets us anything. No. And we'll go... Yeah. So there's our foreign key. Our foreign key references this table on a particular column. There's the reference column right there. But I'm not going to define it. We're just going to jump straight on to joins because we're running out of time. And there we go. Each one of those refers back. Referential integrity, when you can create a constraint like that, you're saying, I will never have orphaned records. We are requiring in here that if there is a value in favorite beer ID, there had better be a beer that exists for that ID. Once we make our constraint, if we try to run insert into lumberjack Lee Smith 20, it's going to fail because, well, there's no 20 in there. But we skipped over the foreign key constraint. Okay, so beer and lumberjack. Let's get on to joins, because joins are really impressively important. Yep. 3 different flavors of joins. Inner join says, for every row in my first table, I want to make absolutely sure that there's a match in my second table. And let's go ahead and see what that means. So we select star from beer. We're going to inner join lumberjack. And we've got to have a specific way to join them, right? And the way we refer to when we've got more than one table in a select statement, we say, okay, table name dot column name. So our table name is beer, and we're referring to the primary key ID matches lumberjack dot favorite beer ID. Now I know we're kind of getting a little bit not advanced, but we're moving forward a little bit quickly. What we said here was, okay, get me everything from both tables, and we should probably be more specific about this. Say, I want all the rows from beer, and I want all the rows from lumberjack dot star, where the lumberjack's favorite ID matches the actual ID. Yeah, no, I'm sorry. I'm a little flustered from the lack of time. So, okay, Lee's favorite beer is number 2, Sweetwater. So we got everything from our first table. That's the beer. And we got everything that matches in the second table based on that join. Does that make sense? Okay, good. That's an inner join. We only got the rows that match. Outer joins say, I want to get rows that match, and I want to see rows that don't have a match. And there are two different kinds. I want to see, well, 3 different kinds. I want to see both sides, rows that don't have a match. So let's do the same thing with a full outer join on lumberjack.
Get rows that match and then...
Okay, full outer join says, okay, I want for everything in the first table, see what matches in the second table. If a row in the first table doesn't have a match, display it anyway. If a row in the second table doesn't have a match with the row in the first table, display it anyway. And we'll see what that looks like. So give me everything. You know what, let's narrow this down a little bit because we don't need all the columns, like I said before. We just want the beer name, and we just want the lumberjack full name, and we'll see. Full outer join, right. Give me everything even if it doesn't have a match. Well, we've only got 2 beers in the left-hand table. This one didn't have a match. This one did. We've only got 1 guy in our right-hand table. And he matched up because we said, well, that has to match. That's a full outer join. Left outer join says, give me everything for my left. That's the first table that you list. It's leftmost if you put it all in one line. Give me everything. Hang on. I'm going to get myself confused in the middle of a demo. Yes, all rows from the left, even if they don't have a match. And you know, if there's a row on the right-hand side that doesn't have a match, don't display that. So left says give me everything from left. Similarly, right, and your right table is, if you had it all on one line, your rightmost table, right? Give me everything on here from the right-hand side. You'll notice we only have Lee, Smith, and Sweetwater because Lee is the only guy in the right-hand table, and the other beer, Harp, didn't have a match. But that's on the left side. We don't care about the left side. This is right on join. All right. I may have to go ahead and leave it there because we're starting to rush through stuff. Oh, hey, look at that! The second to last slide. Bonus. Timed that better than I thought. So bonus material, we used. We did use DB name, even if you didn't notice it. That's just a T-SQL way of doing this. Let's see. I'm going to switch databases. I'm going to switch databases again. If I say use speak, then it's going to use that database. SP help gets us information. Alter table changes the table structure. And we didn't actually use get date or date functions, but get date tells you the current date and time. So select get date. That's kind of a real basic, everybody uses it kind of thing. All right. So, yeah.
Previous slide, she had GUI. Was it to get the you had GUI out there? Same size as identity, you had GUI.
Good. Yes. Good. We talked about that in I said in the last session, but I don't know that any of you were in the last session. Where's the GUID? The other way, and I skipped past it because generally speaking, you don't want to use GUIDs. A GUID is a global unique identifier. What that means is you can have SQL generate, here, let's go ahead and do a little thing real quick, a unique identifier that is unique across the entire universe. There are something like, I worked it out, there's something like 100 trillion possible GUIDs. So with very, very few exceptions, you're not going to get a duplicate anywhere in the world, which sounds awesome. I mean, a globally unique identifier, I want that as my primary key, right? No, and the big problem is that they're huge. And we didn't get onto indexing, because again, this is kind of a very intro class, but you create an index on a table is very much like an index in a book. You know, it says, okay, here's everything in an order, and here's a reference to go and find it. They're actually separate structures, most of them separate structures. And there are a lot of things that you do with your data in consideration of the indexes because they take up so much room and so on and so forth. But anyway, so if we declare a GUID, and the actual data type is unique identifier, and then we set GUID equal to, the way you generate a new one is new ID. That's a GUID. That has never come up in the history of the world, and will more than likely never come up again. Again, there are statistics and probabilities, it may, but it's very, very, very unlikely. But look how huge that is. We talked about needing small primary keys to reference to help SQL do it faster. Well, that's huge. That's 16 bytes? Did I get that right? It's really, really big. Here, let's look it up in books online, which you should do a lot. I'm getting people at the door. You can come on in. It's okay. This is my friend. She's cool. And anyway, so that's what a GUID is. And you very rarely need an identifier that's unique. Well, I'm going to remind you real quick to do your evals real quick so we can do the drawing. You very, very rarely need something that heavy hitting. It's like getting a sledgehammer to pound on a nail. You don't need it, and it's way too heavy. So that's that.
Can you explain us about the cluster and the non-cluster?
Yeah, clustered versus non-clustered index. A clustered index, very, very simply, you can only have one on the table because it physically orders the table itself on disk. And for you advanced people, yes, I know that's not strictly the case, but essentially speaking, it does. So don't correct me. It really does. You can't physically order it on disk in more than one way, which is why you only get one. Non-clustered indexes are a separate structure apart from the table that point back to that primary key. So that's another reason why you need small primary keys, so that you're not making your indexes huge automatically just by having every pointer is to a 16-bit thing. That's the basics. That's the long and short. You want to use your clustered index on the most selective, most commonly searched against column, and if you can, the smallest. So, in a people table, thank you. We'll draw for books now. In like a people table, if you have Social Security done as an ID, that'd be a good thing to cluster on if you search on that most often and join on it. All right, actually, I'll let you guys pick which one you want. For this first one, okay, ticket number 941522. All right, and you can pick which one you like.
Super advanced books.
Yeah, I tried to pick one.
Maybe you can
trade with somebody at your user group.
At the end of the day, so.
And we've got Daniel and Dara. The man that was nodding. I'm glad you won because you nodded a lot.
Oh.
I like people to nod. I do. Well, you gotta look at people. And it's either Andy, Audrey, or Huggy Bear. I can't tell which one.
Huggy Bear, that's me.
Huggy Bear, come over, Huggy Bear, and get a book.
Big giveaways are happening in the big rooms back here.
Big things happen. Yes, Ush. Hey, thank you guys so much for coming. If you have any questions at all, please feel free to email me. Follow me. Look at all my videos. Demand new videos to help you. Thank you.